Graph the system of inequalities. Y is less than or equal to 2x plus 1, and y is greater than or equal to negative 1/2 x minus 2. So in order to graph this, what I would need to do is just start with the first line inequality and treat it as an equation to begin with, because the basic graph is going to be a line based off of the equation y equals 2x plus 1. Which would have a y-intercept of positive 1 and a slope of 2. So if I go up 2 and over 1, up 2 and over 1, or down 2 and back 1, and so forth to get a few more points on this line, then that's good. Now I just need to decide if it's going to be a solid line or a dashed line. And it comes down to the inequality. If it's less than or greater than, we would use a dashed line because that represents exclusion. If it's less than or equal to or greater than or equal to, we use a solid line, which represents inclusion of that point. So in this case, we want a solid line. Now we have to shade. So we're either going to shade to one side of the line or the other. In order to choose, I would just pick the origin, as long as your line's not passing through the origin. Plug this into the line equation. So if I plug the origin in, I get 0 is less than or equal to 1, which is a true statement. So what that means is I would shade this side of the line that contains the origin. Now I go down to the other line. So the other line here, I have y is greater than or equal to negative 1/2 x minus 2. Which has a y-intercept of negative 2 and a slope of negative 1/2. So if I go down 1 over 2, down 1 over 2, there's a couple of points, or up 1, back 2, up 1, back 2, and so forth. Now, because it's greater than or equal to, I would include the boundary, which means I would draw a solid line through these points. And I have to choose which way to shade, and it's usually best to just use the origin if you can. So plugging the origin into the line equation, I get 0 is greater than or equal to negative 2, and that is also true. So I shade the part of the line that is containing the origin. So the region where all these solution regions overlap, that's the solution to our system, which I'll just kind of shade quickly here so you can see it better in just 1 second. All right, so it's that region right there. And if I erase these others, that'll make it a little bit more clear. So there we have it. Okay, so this is certainly a different set of line equations, but the way we do them is the same. So the first line equation is y is greater than x minus 2. So you want to choose a dashed line or a solid line based off of the inequality. So you want a dashed line. Then what I would recommend is pick the point that is your y-intercept, so negative 2. And then we have a slope of positive 1. So then up 1 over 1, that gives me another point on the line. I'm done graphing the line. Now I just move my pencil here, that's on screen, into one side or the other. And that's where you just have to do the same sort of test to decide which way it's going to go. So if you choose the origin and plug it into this equation, you would get 0 is greater than negative 2. Since that's a true statement, just click there, and now that will stay shaded, and you finished graphing that line. So then the other line, y is less than negative 1/2 plus 1, it's also a dashed line, has a y-intercept of positive 1, and a slope of negative 1/2, so go down 1 and over 2. And then you have to decide which side of the line you want to graph or shade. So we'll try the origin again. So that would say, if you plugged in the origin here, that would be 0 is less than 1, which would be a true statement. So there you go. Now when you click, it will stay and you've graphed it. So at this point, the overlapping regions, which are in purplish here, that's the solution region for the system. So if I submit this now, there we go.